Hey there kids, welcome to another math video. This is for Eureka Math, grade 5, module 1, lesson 14, homework. I know that's a mouthful. Anyway, this is a very important lesson and you've heard me say it before. I'm going to say it one more time. If you have not watched the problem set video, please go watch that first. It has all of the information about what we're doing with this crazy place value chart and how we're going to tie it in to the standard algorithm. Please go watch that first, then come back to this one. If you have watched that one and you're ready to start your homework, then bravo, here we go. We're going to be using the place value discs on the place value chart to solve and then connect each step to the standard algorithm. So the standard algorithm with division, fun, easy. We'll get back to it in like module 2 and probably 3. But don't forget, when we're working with decimals, we are going to place this up here because you've got to include that in your answer. Very important placement of the decimal. Also, keep your work neat because it can really throw you off. Most kids make errors because of messy work. So how do we do this? We are going to be writing the place value discs into their chart location. So if I have 5 in the ones place, we're going to do our 5 dots. 1, 2, 3, 4, 5. I like to make 5 across. I try to keep it consistent. You should too. Then we have 2 in the 10ths place, 4 in the 100ths place, and 1 in the 1000ths place. Now this is what we're sharing. The 3 is our divisor. That's down here, 3 groups. So when you have enough to share, you're going to place these discs into these compartments or spaces, the 1, 2, 3, and we're sharing it evenly. So I've used up 3, but if you don't have enough to share, you cannot deposit them here. What we have to do is we have to regroup. Now remember about place value. 1 in a higher position is worth 10 in a lower. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. Okay, so these two are now accounted for in a lower place value position. We're going to regroup them down here so that we can continue dividing. We have to account for all of these discs or all the value of this that's being divided, the dividend. So what happens with this in the standard algorithm? Take a look over here because we're connecting the place value to the written method, the standard algorithm. So we have 5 items that are being shared evenly into 3, but there's only enough for 1 of each to be in these little categories. When I share them evenly, I'm using 3 of them. 1, 2, 3. Using 3. Find the difference, that's the 2. When I regroup these 2, I now have 10, 20 plus 2, 22 tenths. 22 tenths is now what I'm dividing by 3. 22 divided by 3. A lot of people will not bring the decimal down here. That's okay. Only up here is where you really need it. But if you have it down here, it helps you understand the place value and what's happening with your number. Okay? So when I have the 22, I want to say, well, how many groups of 3 can I fit into 22 without going over? And again, we want to find out the most possible. So that's going to be 7 times 3 would give us 21. So take these, and I'm not going to draw the lines because that would be too messy. So if I have 5 and then 2, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Then 1, 2, 3, 4, 5, 6, 7. That's 14. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, that makes 1 left. Do the subtraction over here and find the 1 that's left. Out of the 22 tenths, I've used 21 of them. 7, 14, 21. And there's 1 left up here. Boop. This is the one we're going to regroup It could be any one of them. That's fine. But 1 up here is worth 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When I have 4 in the hundredths place, and I combine that with the 1/10 that I had left, that gives me 14 hundredths. Okay, now it's accounted for here. 10 plus 4 is 14 in the hundredths. That's what's happening here. Now I'm going to share the 14 into these 3 groups evenly. So how many can I maximize with my 3? Well, if I'm using sets of 3, I could have 4. 4 times 3 is 12, and I will use 12 of those hundredths with 2 left over. Show it over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many does that leave left over? 2, which I am then going to regroup with the 1 that I had in the thousandths, in case I didn't make that clear. So it's 21 thousandths. Let's make our tens here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are now accounted for. And I have a total of 10, 21. 21 thousandths. And hopefully you know, because you already solved it here, that 21 of these discs will fit evenly into the 3 as our divisor, the 3 boxes. Okay, so it's going to be 7 in each one to use all 21 with nothing left over. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7, 14, 21. All used up. Every single one of them is accounted for up here. And now you know how many. This is your final answer. And what's curious here is that the answer would be one of these sections. Okay, so see that it's 1, 7, 4, 7. And so that's what we're doing with the place value chart and connecting to the standard algorithm. Sometimes kids will do all these dots and it's kind of crazy and they totally forget this part. And I'm like, oh my gosh, this is the whole point of the lesson, is to make the connection. So you really have to make that connection. Okay, hang in there. It's very, very important. Okay, next one. Again, they've got the chart, but now they're pulling away your scaffolding. Remember that your divisor is the number of sections on the bottom. You don't really need a ruler, but you just need a steady hand. Please try to be careful. 1, 2, 3, and 4. That's your divisor, is 4. Then we're going to take our 5.372 and make those discs up here. 1, 2, 3, 4, 5 ones. 1, 2, 3 tenths. 1, 2, 3, 4, 5, 6, 7 hundredths. And 1, 2 thousandths. Same thing. We're going to start sharing them, and then we're going to show the standard algorithm. So I have 5, and I have to share 4. That means we're going to have 1, 2, 3, 4 that are used up. 1, 2, 3, 4, with 1 left to regroup. Make your 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it's accounted for. Now here I have 13. Let's see what happens over here. Divide 5 by 4. 1 in each group, using a total of 4 with 1 left over that gets regrouped with the tenths. Now I have 13 tenths. Okay? When you take your 4 and the 13 that you have, you're going to be sharing evenly so that, decimal up, 3 times 4 will use 12. If you wanted to take these and count one at a time, because you have the 13, you go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's all 10 of these and 2. 1 is left over. Look, 13 minus 12, 1 is left over. Regroup that with the hundredths. The 17, the 7 that I already had, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 17. Then we're going to take the 17 and divide by 4. And so use up as many as you can without going over. That will use 4 in each group for a total of 16 hundredths. That will be taken care of with 1 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Left over, move it. Okay, left over, left over. One of these is worth 10 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it's accounted for. Here it is. Group it with the thousandths place. Total of 12 needs to be shared into 4 groups. How many? 3 in each group, using all 12 with a remainder of 0. Okay, sorry if that was too low, moved it up. And so there's going to be 3 in each group so that you can use them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They're all accounted for. Okay, and so that's how you want to tie the place value chart to the standard algorithm. Very important concept, very important tie-in. Now that you have done that, oh, now that it's blurry, now that you've learned all that place value stuff, we're going to be using the standard algorithm. So the goal is to always move away from the concept and to really apply just the numbers, because you'll never really see the place value charts out there in the world. So take what you know is your divisor, and that's going to go on the outside of your bracket. Make a nice neat bracket, give yourself lots of room, put in the whole dividend, 64 hundredths, and decimal up first thing. Okay, we don't want to forget that. Now we're going to start dividing. Okay, now there is nothing in the ones place, so 0 times 4 is 0. Normally I won't do this ever again because why waste the space? Okay, 6/10 is our dividend. This is what's being shared into these 4 groups. There would be 1 in each group using a total of 4. There will be 2 left over, which we will then regroup with the 4 in the hundredths place. When I say hundredths, you didn't see me going, okay? 24 hundredths is what we have. We're sharing that evenly into the 4 groups. And if you know your facts, you know that 6 times 4 is 24, and that will have 0 left over. So your final answer is 16 hundredths, and using the standard algorithm this way. So once you figure out how to do all those little discs and the slashing and the sharing, you really won't do it anymore. So you have to do it 2 times on the previous page, and then they say, okay, never mind, until tomorrow's lesson, lesson 15. Okay, so here we go again. 5 is the divisor. 6.45. This is the dividend. Decimal up. It's not going to move, so anchor that. We have 6 ones. I have enough to share into all 5 groups so that 1 could be in each group. We're going to use 5 of them with 1 left over. Regroup that with the 4 in the tenths place, and now we have 14 tenths. Divide that into the 5 groups. We can use 2 in each group, which makes a total of 10 being used. Multiply, subtract to find the difference, and see that there are 4. Aren't you glad we don't have to draw the discs now? 4 that would have to be regrouped with the 5. So that would make a total of 45 of those little discs in the hundredths place. Divide this into the 5 equal groups. Anything that ends with a 0 or a 5 is an exact multiple of 5, and it is exactly divisible 9 times using 45, all up with nothing left over. Some of you guys might be saying, why are you not consistent with your decimal? I just don't. When I learned how to do division, we never brought the decimal down, but I like to show you what's happening so you can understand, hey, guess what? It's all about place value. So your answer, 1.29. And our last one, 6 into 16.45. 0.404 or 16 and 404 thousandths. So now we're dividing, but you might notice that 1 is not divisible by 6, but I can regroup that right away with the 6 ones for 16. So here's where my first digit is going to go. And how many groups of 6 can I make? Well, I can make 2 groups of 6 or 6 groups of 2 to use 12 of those with 4 left over. And then I would have to regroup that with the 4/10. That's a lot of discs. Thank goodness we're not doing place value discs here. I have 44 that's being divided by 6. I can put 7 in each group. 7 times 2 is 42. I'm sorry, 7 times 6 is 42. My bad. And then subtract 2 left over, which I would regroup with the 0. Don't skip it. It has value here in this spot because there's a 4 in the thousandths place. There are 0 hundredths, so regroup the 2/10 with the 0 hundredths for a total of 20 hundredths. So that is divisible. 20 hundredths is divisible 3 times. Okay, if I had 6 groups, I could fit 3 in each group. 3 times 6, 18. With 2 left over, bring all the way down to here, the 4. So what am I on? I'm on 24 thousandths divided by 6, or into the 6 groups, which would mean 4 in each group, using all 24 with 0 left over. Final answer, 2.734 or 2 and 734 thousandths. You getting the hang of it? Does it seem okay? I hope so. All right, word problems. Here we go. Mrs. Mayuko paid $40.68 for 3 kilograms of shrimp. What's the cost of 1 kilogram? So if that's for 3, we have to divide that into the 3 pieces. And a tape diagram would be something like this, where you look at the total cost, and each one would be 1 kilogram. And so since she paid $40.68 for the 3, the question is, what is that? And so a tape diagram can help you see, what am I doing with these numbers? Well, I have to divide this into the 3 sections. So 3 is my divisor, decimal up, and this is my total cost. So now we're just doing standard algorithm. You don't need a place value chart unless you really feel like it's going to help you. So 4 in the tens divided into 3 sections. Guess what? I have enough to put at least 1 in each section using 3 of them, with 1 left over, and I'll regroup that into the ones place. I can divide 10 by 3, or into 3 sections, using 3 in each section. 3 times 3 is 9. We would use up 9 of the discs with 1 left over, which I could then regroup with the 6/10. And there go the lights, because it's always so exciting in here. Lights out! So now we have 16/10 divided by 3, or into 3 sections, which I could put 5 in each one, using 15 with 1 left over. Finally, bringing down the 8 in the hundredths place, so I have 18 hundredths divided by 3, evenly can fit 6 in each one, with a remainder of 0 that I squeeze down there right above the word sugar. So $13, because this is money that we're sharing. The cost of 1 kilogram would be $13.56 for 1 kilogram of shrimp. And click subscribe and come back again. I'll try to help you with more math. Here we go. Subscribers and non-subscribers alike, I hope I'm helping. The total weight of 6 pieces of butter, 6 pieces, and a bag of sugar is 3 8/10 pounds. If the weight of the bag of sugar is 1 4/10 pounds, what is the weight of each piece of butter? Here's another place where a tape diagram can help you see the whole. So we've got the butter and the sugar, and the total weight of those things, the butter being 6 pieces, 1, 2, 3, 4, 5, 6, and the bag of sugar, and that's 3.8 pounds. That's the total. So what we need to find out is how this weight of the bag of sugar at 1.4 plays into our equation. So I need to find out each piece of butter. I need to find out one of those right here. So what can I start with? Well, I can start by taking off the thing that I do know. 3.8 minus the sugar, pounds. Try to label everything. It will really, really help you. So take off what you do know, which is the actual weight of the bag of sugar. 8 minus 4. 4. Decimal down. 3 minus 1. 2. That's what's left. Okay, so this is given. This all is 2.4 pounds. But now I need to divide that into the 6 pieces. So this is our today's lesson. Decimal up. Pounds for one of the 6. So I'm dividing the total by 6 so I can figure out how much each one is. So 2 is not divisible by 6. We're going to put a 0 there to hold that spot. And then I'm going to regroup those two so that it would be 10 and 10 for a total of 20. Now I have 24 tenths. So 24 tenths being divided by 6 can make 4 in each group for a total of 24, using them all with nothing left over. So that each piece of butter is 4/10 pound. And then you can check yourself if you wanted to and add it back up and do 4/10 pound times 6 to find out what you get. And then you can add those two together to get the 3.8. So anyway, you can check yourself going in and coming out, and hopefully this has been very helpful for you. I hope to see you on another video. Goodbye for now.